Welcome back to Mr. Leek's free science tutorials. Now the question I'm going to be dealing with in this video is, what is radiation measured in and what are its uses? Everybody always thinks, nuclear bombs, all these kind of things where the uranium, the plutonium, whichever element it is within a bomb, right, that is one of the main uses, which I guess it is, right, but obviously it's something that we'd rather not happen, right, because it probably wouldn't go too well for planet Earth. So what is radiation measured in and what are its uses? I'm going to go through two main ones, right, and then I'll talk about maybe a couple of others, right, that are also ways in which radiation is used around the home and for people's work. So radiation is measured in something called sieverts, right, and the spelling of it is the most important thing, S-I-E-V-E-R-T. Now, the reason why radioactive substance can be used, right, particularly in medical places, is because they have different half-lives. Now, we talked about half-lives in a different video, right, but basically half-life is the amount of time it takes for half of the substance to decay. Something like uranium, right, uranium has a half-life that is thousands of years. Right, so if I had a lump of uranium on my back garden, right, it wouldn't be safe to go near that for however many thousands of years, right? That's its half-life. Where other substances have very short half-lives. So there might be a substance that they might use at the local hospital that might have a half-life of 30 minutes. So they inject something in, 30 minutes later, half of it's decayed, another 30 minutes, and so then it disappears quite quickly, which then means it hasn't got the same sort of damaging potential, ionizing potential. So here it says, different isotopes have different half-lives. Short half-life used in high doses, long half-lives used in low doses. Now, the uses. Quite often, right, if you then have some form of issue, whether it's a blood to do with your heart or intestines, right, then what you can do is you can then have a tracer that's put into your body. What a tracer is, it's an isotope with a short half-life injected and allowed to circulate and collect in damaged areas. So basically what they'll do is they'll have a liquid in a needle, they'll inject it into the person. This is a radioactive substance, and what it'll do in the blood, it'll go round and round the body, and then it's designed to collect in certain areas. So if there's a problem in the brain, then what it'll do is that individual isotope will then collect in the brain. Then what they'll be able to do is they'll be able to use a PET scanner used to detect emitting radiation. Now it must be beta or gamma, as alpha does not penetrate the body. So the actual decay within there has to be beta or gamma, because alpha would only penetrate a very, very small distance from where the substance went in. All right. Now it says here injected. Sometimes you can have some of these as a drink, right? And I know my wife had one once and she had to drink some like 2 pints of this liquid, right? That liquid then goes into her. She then goes back an hour later and then it's gone around her body. So tracers. Another one is radiation therapy. It's used to treat illnesses, for example, cancer. And again, talking about my wife, she had radiotherapy. Right, for 4 weeks solid, 20 different occasions she had to have radioactive or radiation therapy. And what it does is the cancer cells are killed by gamma rays. So a high dose used to kill cells. Now, if you think about it, it's gamma rays. Gamma rays can go through things very, very easily. So what they do is they focus the gamma rays into a certain point, and it's a bit like a gamma knife, where it's almost killing in a certain focus point in the body. Damage to healthy cells is prevented by focusing the gamma ray gun. All right, so if you think about it, all right, there's a cancer within the body, and what they'll do is they'll focus it from all sorts of different angles to focus on one individual point, and where that point is, that's where all the gamma rays are, that's where the cancer is, so it only damages cells in that area. Now, obviously, because you're sending radiation through all sorts of different parts of your body, you can get other issues. So, what is radiation measured in and what are the uses? Radiation is measured in sieverts. Its uses are as a tracer that is used within the body. It's where an isotope with a short half-life is injected, allowed to circulate and collect in damaged areas. You then use a PET scanner used to detect emitting radiation. And what it'll do, it'll get a picture of the radiation that then is coming out of a certain area. The decay must be beta or gamma, as alpha does not penetrate the body. It doesn't escape. Another use is radiation therapy, used to treat illnesses, for example, cancer. Cancer cells are killed by gamma rays. High dose is used to kill the cells. Damage to healthy cells prevented by focusing gamma ray gun. So that then answers the question, what is radiation measured in? Sieverts. What are its uses? Tracers, radiation therapy. They're two key ones. Two other ones that you might be aware of is your smoke alarm in your house, right? That has a very, very small source of alpha radiation in it. And basically what's happening is, within that smoke alarm, the alpha radiation is passing across a very, very small gap, right? Now we know that alpha radiation doesn't travel very far in air, right? And so what the detector on the other side is, as it's detecting the alpha radiation, the alarm doesn't go off. As soon as smoke goes in between or into the smoke alarm, the alpha then can't get across the gap. And as soon as the detector can't detect the alpha radiation, right, then the alarm goes off. Another good example is using radiation to sterilise things, right? So what they'll do is they'll have machines in hospitals that will then bombard hospital equipment, knives, all those sort of things with gamma radiation to kill off any bugs and bacteria that basically don't die in boiling water. So back to the question, what is radiation measured in and what are its uses? To answer that question, they are measured in sieverts, they are used as tracers and radiation therapy with a bit more detail added.